We are going to go fairly quickly through stuff today because we did a whole bunch of practice yesterday with figuring out what to set up and what equations to use here. So remember, we're going to write down all three sides and all three angles, and you want to start by writing down the information that you have given to you. So you should write down that A to B is given to be 20, B to C is given to be 30. Our right angle, angle B, is 90, since it's a right angle. To solve for the rest of them, let's take a look. I'm going to start by solving for A to C. You can start anywhere, but I'm going to start with solving for A to C. A to C, I know two sides, and then I have a third side that I don't know. So I'm using two sides that I know to solve for a third side that I don't. And so anytime I'm doing that, that's going to be Pythagorean theorem's job. Pythagorean theorem is in charge of, I know two sides, I'm trying to solve for the third side. And A to C, what we're trying to solve for is our hypotenuse. And so we have, that goes on the left side, 20 squared is 400, 30 squared is 900, so we get square root of 1300, which is the 36.1. Side lengths go to the nearest tenth. Now, I'm going to solve for angle A next. So if I'm solving for angle A, now I'm using those two sides that I know, and I'm using them to solve for an angle. So if I'm traveling from talking about sides to talking about angles, using sides to solve for angles, some trig is going to be happening. Which trig? Well, what I know with angle A is opposite is 30 and adjacent is 20. I didn't have the hypotenuse in front of me. So I have opposite and adjacent. Opposite and adjacent, that's going to be tangent. And since we're trying to solve for an angle that we don't know, that's going to be inverse trig's job. The angle's going to get rounded to the nearest whole number and be 56 degrees. Then, as soon as we have one of the angles, we can subtract from 90 to solve for the other. Remember, that's because one of the angles, all three of the angles have to add to 180. The right angle is already 90. That leaves 90 for the other two put together. So we take and subtract from 90, and we get 34. As our last angle measure. So once you know one of the angles, very easy to get the other angle. Very quick and easy. So we're starting this one on your own. I'm giving you another about 30 seconds before I start it. Hopefully we've written down the information. And hopefully you've gotten angle U, because to get angle U, I just need to take the angle and subtract it from 90. Same way I did before. As soon as you have one of the angles, subtract it from 90 to get the other angle. And now I'm going to solve for U to T. That's what I'm going to look at. Here's my angle S. What do I know? I know hypotenuse, right, across from the right angle. I know hypotenuse. I want to solve for opposite. Here's where adjacent is. So I know hypotenuse. I want opposite. So opposite and hypotenuse, that's going to be sine's job. So pausing here and giving you a moment to solve the rest of it. Here we go. Get rid of your fraction by multiplying by what's on the bottom. Your side length goes to the nearest 10. Remember, the angles go to the nearest degree, your nearest whole number. The side lengths are going to go to the nearest tenth. So that one was T to U was 14.1. And now if I'm trying to solve for T to S, I still have hypotenuse in front of me. But now I'm trying to solve for adjacent. So I've got hypotenuse. I want adjacent. That's going to be cosine. And we're going to solve. And we should get that being about 5.1. So that one I was much more kind of giving you checkpoints along the way, saying here's this step. Now take a few moments to solve the rest of it. This next one, I'm going to give you about 3 or 4 minutes. Try and solve this one on your own. Pause and solving this one on your own. And then I'm just going to show you the whole thing all at once. So about 3 or 4 minutes. Try and work on this one. Here it comes. I started by solving for A to B. If I know 2 sides and don't know the third, that's Pythagorean theorem's job. Hypotenuse was the 26. 26 was across from the right angle, so it went on the left. Solved it down, you should have gotten 21.9. Then if I'm solving for angle A, then I'm using opposite and hypotenuse. Opposite and hypotenuse, that's going to be sine. And since we're solving for an angle, we need the inverse trig. And as soon as I know that angle, I'm going to subtract it from 90 to get the other angle. So angle A was 33, and angle C was 57. So in general, when we go to solve these, we've been doing our side lengths to the nearest tenth. We've been doing our angle measures to the nearest degree. When you go to do your assignment on Savas, do make sure that you pay attention to what it asks you to round to. I think most of the time it matches what we've been doing. But make sure there should be a little text in blue that says, hey, here's how to leave your answer. Make sure you know what it might ask you to round to. If it wants you to leave your answer as a fraction, then make sure you do that. But that is the process. This is why yesterday we spent a whole bunch of time practicing. Here's what to use in what context and what information. So to go over it one more time, I knew two sides. So to get the third side, Pythagorean theorem. I knew two sides I wanted to get to an angle. That was the inverse trig. Once I knew that angle, subtract it from 90 to get the other angle. That was our process on that one.